we'll be reviewing 3 calculus topics. The first derivative test, to find where a function is increasing, decreasing, or their extremes. The second derivative test, to find a function's concavity and its inflection points. And finding the area between 2 curves. The first derivative test is to find where a function is increasing, decreasing, or there are maxes or mins on a function. In order to do this, the first thing we need to do is take the derivative of the function. Then we set the derivative equal to 0 or find where it's undefined. Then we'll make an f prime sign chart to see where the derivative is positive or negative. If it is positive, then the original function is increasing. If it is negative, then the original function is decreasing. If the derivative is changing from positive to negative, then there is a max on the original function. If it is changing from negative to positive, then there is a min. On a closed interval, endpoints can also be extremes. The second derivative test is used to find when a function is concave up, concave down, or there are inflection points on the function. An inflection point is where the function changes from concave up to concave down, or from concave down to concave up. In order to find the concavity and inflection points on a function, we need to take the derivative of that function twice, thus the second derivative test. We set the second derivative equal to 0 or find where it's undefined and make an f prime sign chart. If the second derivative is positive on an interval, then the function is concave up on that interval. If the second derivative is negative, then the function is concave down. If the function is changing if the second derivative is changing from negative to positive or from positive to negative, then there's an inflection point. Let's use the first derivative test and second derivative test to find the maxes and mins and the points of inflection on this function. F of x equals 3x to the third minus 3 halves x squared minus 2x plus 7. The derivative, f prime of x equals 9x squared minus 3x minus 2. We set the derivative equal to 0, and we get that x equals 2/3 and x equals negative 1/3. Then we make an f prime sign chart. To the left of x equals negative 1/3, f prime is positive. In between negative 1/3 and 2/3, it's positive or negative, and to the right of 2/3, f prime is positive. This means that there's a max on f at x equals negative 1/3, and there's a min on f at x equals 2/3. Using the second derivative test, we take the derivative of f prime and find that f double prime equals 18x minus 3. We set this equal to 0 and get x equals 1/6 and make an f double prime sign chart. To the left of x equals 1/6, f double prime is negative, and to the right of x equals 1/6, f double prime is positive. This means that f is concave down from negative infinity to 1/6 and concave up on 1/6 to infinity. And there's an inflection point on f at x equals 1/6 because the second derivative is changing from negative to positive at that point. Next, we're going to review finding the area between 2 curves. In order to do so, the first thing you want to do is to make a graph of the 2 curves so that you know which one is above the other or which one is to the right of the other. Then, we're going to take the integral of the top function minus the bottom function with respect to x, or the right function minus the left function with respect to y. Then we'll set the functions equal to each other to find out what the bounds of the integral are. For example, if we have f of x equals negative x squared plus 2 and g of x equals negative x, and we want to find the area between these 2 curves, we first want to graph the 2 functions. We find that negative x squared plus 2 is the top function and negative x is the bottom function. We can set these 2 functions equal to each other to find that they intersect at x equals negative 1 and x equals 2. So those are the bounds of our integral. Since this is the top function, we want to take negative x squared plus 2 minus negative x with respect to x. We can factor out the negative and integrate x squared minus x plus 2. And using FTC, we will find that the area between the two curves is -1 and 5/6 units squared.